You're welcome to Tech Talks Education, and we are still proceeding with the preparation of alkanes from alkylhalides and the preparation of alkanes from number 3 alkyl halides from really alkyl halides. Now, we have looked at so many cases on how we can obtain alkanes from alkyl halides, but this time we want to look at how we can obtain alkanes from alkyl halides by hydrolysis. By hydrolysis of grignards. Hydrolysis of grignards reagent. You can write this by capital letter because it is the name of a human being. Grignards reagent. So it is Grignard, a human being called Grignard, who discovered the reagent. And after the reagent became so useful in organic chemistry, it was named after his name as Grignard's reagent. But Grignard's reagent itself, reagent is alkyl magnesium halide. It is alkyl magnesium halide of general formula R, M, then X. RMX, whereby this R is simply an alkyl group, then the Mg is magnesium, and X could be chlorine, could be bromine, could be iodine. That is the composition of Grignard's reagent. Now, before we can look at how it helps us to obtain an alkane, we want to start by looking at how do we prepare the Grignard's reagent. How, therefore, can we obtain Grignard's reagent? So I want to say that Grignard's reagent is obtained when we react an alkyl halide with magnesium in the presence of dry ether. If we can react an alkyl halide with magnesium in the presence of dry ether, then we shall prepare this one. And that one is what we are calling a Grignard's reagent. The formation of this bond is a bond between a carbon and a metal. It's between a carbon and a metal. So therefore, in advanced chemistry, we call it an organometallic. Organometallic is simply a bond between an organic compound and a metallic element. So when they form Grignard's reagent, so by the way, Grignard's reagent is an example of an organometallic compound. So really, it is so useful. It is so useful because it is also one of the methods helping us to prepare an organometallic compound. Now, after looking at how we prepare Grignard's reagent, we can now look at how we use Grignard's reagent to produce an alkane. So this is my Grignard's reagent. Possibly, let me call this one this time bromine. And we are saying that when hydrolyzed, that is hydrogen ion in the presence of water, should be able to prepare for me an alkane. Should be able to prepare for me an alkane. Should be able to prepare for me an alkane. So this is ethyl magnesium bromide. That is the name of that Alklyhalides reagent. So when I hydrolyze the Alklyhalides reagent, I should be able to obtain an alkane. So the mechanism starts here, that I'm having a water molecule, and we are quite well aware that a water molecule has a lone pair of electrons on oxygen. The lone pair should be close to itself as well as close to the oxygen atom. So this proton receives electrons from the lone pairs of the oxygen atom. And when that is happening, then we should be able to get a hydroxonium ion. It carries a positive charge on oxygen because this time the oxygen is carrying excess number of bonds than it can hold. Now then from there, this organometallic bond is broken so that it can create stability of the hydroxonium ion. In other words, it breaks with an intention of removing one of the hydrogen atoms from the hydroxonium ion, so that this ion could gain stability. And when it gains stability, then it becomes water. So I want to look at this organometallic bond. And I said when I talk about organometallic, I'm meaning a bond between an organic compound and the metal is what I call an organometallic bond. Now, looking at this hydroxonium ion, which could be of that format, it is carrying the positive charge on oxygen. It picks out one of these hydrogens, and then that is electrons are donated back to neutralize the water molecule. They are really donated back to neutralize the positive charge on the oxygen atom. Now this hydrogen is picked to go to the carbon, and remember this carbon is already having two hydrogens. And once it is picked out, then it will be able to liberate an alkane. We'll be able to liberate an alkane like CH3, CH3. But then plus M, Br, and then plus the water molecule. Now, when we look, remember this bond has broken, and all these electrons which are here, the ones we call bonding electrons, the bonding electrons along with this bond have been donated to hydrogen so that it comes here. So now it leaves magnesium electron deficient, and that's why I want to say it therefore should carry. It therefore should carry a positive charge, because we know quite well that magnesium is a group 2 element that uses that donates 2 electrons in order to form an ionic bond. So one of them has been taken and one bonded to bromine. So therefore it becomes electron deficient. But because of the presence of this water molecule neutralizes the positive charge on magnesium by the help of the lone pair of electrons on the oxygen atom. So I'm going to have magnesium. So I can have magnesium bromide. Then I have the water molecule donating its electrons to the magnesium. And when it donates it there, Then we should have magnesium. This one having the proton still, and then it is the oxygen atom having the positive charge, simply because it is now taking up more than the electrons which it can manage. Or I could write it like this. It's now having the positive charge. So then from here, we have what we call proton loss. Yeah, that is the mechanism for the liberation of this alkane. Our target was here, but this was left incomplete and highly reactive, so we had to neutralize it to form this. Now this product formed occurs as a white precipitate. It appears as a white precipitate, and therefore one time we can ask you to state what is observed when alkyl magnesium bromide is hydrolyzed. Of course, we form an alkane as the major organic product, but you can't see an alkane. So therefore, if we ask you of what we observe, then we observe a white precipitate. So that's why it is important to show how the final product of magnesium hydroxide bromide is really formed. That is how we can prepare alkanes by hydrolysis of Grignard's reagent. So the alkane formed is therefore ethane.